Hello and welcome. Today I'll be speaking about power factor correction, what it is, the different types of power, and the advantages of using power factor correction, also known as PFC. So, what is power factor correction? Well, power factor correction is an energy saving technology. Power factor correction can significantly decrease electricity costs by eliminating reactive power charges. The way it is used is by placing a capacitor in parallel with the inductor on the consumer's system or premises. This makes it very efficient for the company because all that is being powered by the electricity supply company is the current that will be flowing through the consumer's resistor. This in turn saves the company a lot of money. An easier way to explain this is by using the beer analogy. So, we pay for a beer by the glass, but inside the glass there is both beer and foam. The more beer we have, the less the foam there is, so we get good value for the money that we spent. If there's a lot of foam, then there's not a lot of beer and we're not getting good value for the money. The beer represents our true power, which is measured in kilowatts. This is the useful stuff we want and we need. This is basically what does the work. The foam in the beer represents our reactive power, which is measured in kilovolt amps reactive. This is the useless stuff. There will always be some of this reactive power and we have to pay for it, but we can't get use of it, so we don't want too much of it. So our goal is to get rid of the foam. So what power factor correction is basically the ratio of useful power or true power in kilowatts divided by what we're charged in kilovolt amps. So it's telling us how much value for money we're getting for the power we consume, basically. Now, the different types of power. So, real or active power. Well, real power is the power which is actually consumed or used by the load in an AC circuit. The energy is converted from electrical energy into another form of energy that cannot be reused by the electrical system. Reactive power. Reactive power represents the electrical power that is temporarily stored in a capacitor or an inductor which can be reused by the electrical system. This in turn can drive current throughout a different part of the circuit. The energy stored is not lost. Apparent power. This is the product of RMS value and voltage. The apparent power represents the power that a company is charged for by an electricity supplier. When the impedance is a pure resistance, the apparent power is the same as the real power. Now, advantages of using the power factor correction. Well, it reduces your carbon footprint. So, by reducing your power system's demand charge through the power factor correction, your company is putting less strain on the electricity grid. This in turn reduces its carbon footprint. PFC also reduces electrical charges. So, most electrical utility companies charge for maximum meter demand based on either the highest registered demand in kilowatts or percentage of the highest registered demand in kilovolt amp meter. Whichever is greater. If the power factor is low, the percentage of the measured kilovolt amp will be significantly greater than the kilowatt demand. And it also, lastly, improves your voltage. So, a lower power factor causes a higher current flow for a given load. As the line current increases, the voltage drop in the conductor increases, which may result in a lower voltage at the equipment. With an improved power factor, the voltage drop in the conductor is reduced, therefore improving the voltage at this equipment. So if we look at this diagram here, this is the system without a capacitor. This blue is the reactive power and the red is the active power. So what we're trying to do is get as much of this reactive power out as we can. If we place a capacitor, this helps get rid of the reactive power and replace it with the available active power. This is what a capacitor basically does. Thank you for listening, and this has been it.